In these videos, we're gonna talk about our serverless cloud architectures for the photo album application. First, we will review the diagram, go through its surface, then explain how it operates by using UML sequence diagram. Next, we will explain how it satisfies 6 pillars of AWS framework. Then is the reason for choosing these new designs. Finally, is going through briefly some achievement and limitations. This is the development of the previous assignment too, but put in a business scenario with requirement for large scales and higher demand. Users first access the system through Amazon Route 53, our global DNS routing service. All incoming traffic is inspected by WAF, which protects the application from common web attacks and bots. Static website contents is delivered through Amazon CloudFront, providing low latency access worldwide. The front end itself is fully hosted on S3 using static website hosting. User authentication is managed by Amazon Cognito, which provides secure user sign and identity management. When users interact with the backend, all API requests go through Amazon API Gateway, which triggers Amazon Lambda functions. Lambda handles all compute in a serverless auto-scaling manner. Application metadata such as user information, media tags, and processing status is stored in DynamoDB, a highly scalable NoSQL database. Secretly, secret and API are managed securely through AWS Secret Managers, and IAM provides the role-based access control across the entire systems. When the users upload photos or video to Amazon S3, the uploaded event is captured by Amazon Event Bridge. Event Bridge is triggers our processing workflows. Tasks are placed into SQS, allowing multiple Lambda worker functions to process then asynchronously and prevents overload. More complex workflows such as branching logics, retries, and multi-step processings are coordinated using Amazon step functions. Images can be analyzed using Amazon recognition to automatically generate text, while videos are translated into a multiple resolution using Media Convert. All the process results are saved back into S3 and delivered globally through CloudFront. For operation, Amazon CloudWatch provides logs, metrics, and alarms, while CloudTrails record all API level activities for audit look. Finally, the entire infrastructure is deployed and version controlled with CloudFormation, ensuring consistency and easily update.
Let's talk about the media upload workflow. Uh, this, this is the entry point to our architecture. So when an authenticated user uploads an image or a video through CloudFront, the request will pass it through a the AWS WAF for security and Cognito for identity verification. Then it would reach the API gateway, which then will trigger a Lambda function. That Lambda function then creates a signed URL, allowing the user to upload directly to the S3 raw data bucket while storing metadata like the file name and the user ID in the Dynamo databases. Once the upload finishes, EventBridge or SNS will emit an event to signal the new media that is ready for processing. Uh, this one, I apologize, will be harder to see. I'll try to make it clear with my speech. Next, there is the media processing flow. The media processing flow will automate everything after upload. So when an object appears in the S3 raw bucket, an object created event trigger event bridge would route the job to either the image or video queue. For images, chain lambda function will create thumbnails, optimize a file, run recognition, detect labels. Sorry, result in the output image bucket and the database. And for video, another pipeline will extract the thumbnail, using media convert for FFmpeg to transcode adaptive and retrain versions and save them in the output video bucket. And finally, a process event is sent back to event bridge to inform downstream system. This is our third figure, figure C on the authentication flow. The authentication flow secures the user access through Amazon Cognito and OpenID Connect. When a user opens the site via CloudFront, they are redirected to the Cognito hosted UI for sign-in. The user pool verifies the credential of MFA, then issues an authorization code. The client exchanges that code for an ID token, access token, and refresh token. Every API request sent through the API gateway includes the access token, which is a Cognito authorizer, validated before forwarding to the Lambda. Move to the final one, which is the content delivery workflow. Finally, the content delivery workflow handles how process media reach user. So when someone views a photo or a video, front-end calls a API gateway and a Lambda function to fetch metadata and CloudFront URLs from Dynamo database. The browser then retrieves the media through CloudFront, which securely fetches it from S3 process bucket using the origin access control. CloudFront cache the content at the global edge location, protected by WAF and encrypted by ACM SSL. Yeah, this will ensure minimum latency across all a wide range of across worldwide. Yeah.
Let's talk about AWS Web Architecture Framework. There are six that are covered in this video. The first pillar is operation excellence, which is carried out by CloudFormation, CloudTrail, and CloudWatch. These services are mostly used for checking, debugging, deploying, and monitoring. For the security pillar, we are using WAF to protect the entire application right on the edge layer. Cognito Secret Manager, IAM, CloudWatch, and CloudTrail could handle both credential protection and auditing log. For the readability pillar, S3 Dynamo Lambda is a serverless service, which means they are managed by AWS, so we don't need to worry about. Other services at Eventbrite, SNS, SQS help decoupling between services to prevent overloading. For the performance pillar, CloudFront is used to give a worldwide experience, which makes users at a different geographic location have a low latency, improving user experience. Other services such as Lambda function, DynamoDB, S3 assure fast images processing, video transcoding, and API response, even during heavy traffic. Cost optimization pillar is our architecture provides services such as Lambda and DynamoDB. We are only trained when we trigger, so we don't only pay when we use them. We are much cheaper when compared to a traditional server-based architecture. The final is sustainability pillar. Lambda and the DynamoDB are good choice because they maximize resource utilization. Another is S3, which is optimized share resource at a large scale.
Okay, so hi, I'm Min, and now I will go over the alternative solutions for our project. So first up, we have EC2 and Lambda. Normally, EC2 will handle traffic, but it has idle costs, which can get very expensive. With Lambda, it is charged per execution, which is much cheaper. Our project is estimated to reach 300,000 users, so we would need over 300 T2 micro instances to keep CPU usage at 60%. This is very hard to manage and is very expensive. Additionally, Lambda can scale faster than EC2, so the app can handle sudden workloads much better. Now moving to Aurora. Regarding scalability, Aurora will scale vertically and DynamoDB will scale horizontally. The scaling for DynamoDB is significantly cheaper. With Aurora, it will cost around $300 a month and up to $3,000 at year 3, whereas DynamoDB would only cost $2,500 for year 3. Additionally, DynamoDB uses NoSQL, which is much better suited for the application since it is faster. DynamoDB has built-in multi-availability zone replication and can also integrate smoothly with Lambda. For Aurora, you need to manually configure redundancy, and it is also more expensive. Now for the API gateway and application load balancer, they both route traffic, but API gateway is more suitable for our project. API gateway has native integration with Cognito for authorization and other serverless components. Regarding cost, AOB has a fixed hourly cost and API gateway charges per request. And we estimate the initial cost would be for AOB would be around $100 a month. However, with API gateway, the first year cost will be only around $100. Also, there's no need for maintenance since API gateway is managed by AWS. And lastly, we will talk about CloudFormation and Amplify. While Amplify does have the capability to create a web app similar to CloudFormation, Amplify is more for mobile and front-end heavy application and is less suitable for our business scenario. For scalability, CloudFormation templates can be reused for long-term scalability and sustainability. And for costs, CloudFormation will charge for interactions between the apps, and so our costs will remain around $4,000 a year, where an app on Amplify would be around $5,000 a month with the expected traffic. I would like to address the other alternatives to CloudFormation as well, such as AWS CDK, since they all convert back into CloudFormation. We will just use CloudFormation. And that's all. Thank you.